In this episode, the world's biggest ship.
We're the widest, we're the heaviest, we're also the longest vessel in the world.
Built to be the most powerful lifting machine on the planet.
Pioneering spirit can do things that other vessels can't do.
Made possible by a raft of cutting-edge inventions.
It's surprisingly strong, even though we know it's made of tissue paper.
What an amazing machine, incredible.
History meets high-tech to make the impossible possible. The offshore oil industry is at a critical turning point. Many shallow water oil fields are drying up, and between now and 2050, many hundreds of rigs will be scrapped.
In the old days, nobody thought of removing a platform, but the idea was to keep it at sea for years. Nowadays, from an environmental point of view, platforms have to be decommissioned.
Standard oil rigs consist of a steel base fixed to the sea floor. This supports the giant topside, holding the drill rig and the processing plant, which can alone weigh over 40,000 tons. Site coordinator Dan Ackerboom knows dismantling these metal giants is far from easy.
The conventional method always was with cranes on a big barge. Removing a platform in the old-fashioned way has a lot of disadvantages. It's mainly because you're offshore for a long time. It's a lot of lifting, and lifting is always a risk, especially for at sea.
With so many rigs requiring decommissioning, the industry needs a radical new approach.
What we wanted didn't exist, so we have to design something differently and something new.
And in August 2016, what offshore construction engineers came up with is the pioneering spirit. For Vice President of Innovations Andre Steenhuis, this $3 billion multi-purpose megaship will change the industry forever.
This idea is quite revolutionary. If you have to do something which you have never done before, it's difficult.
Weighing over 900,000 tons at maximum draft, at 124 meters wide and up to 477 meters long with equipment deployed, this steel giant is the biggest vessel on the oceans. Propelled by 12 6,000 kilowatt azimuth thrusters, this multi-purpose ship can install and remove oil platforms and lay pipeline in the world's deepest waters. And its unique dual-bow design, with 8 pairs of lifting beams, each weighing 1,800 tons, enables the ship to straddle an oil platform and pick up a 48,000-ton oil rig topside in one Herculean lift. Lifting something of such magnitude at sea has never been done before. For the pioneering Spirit team, the engineering feats required were mind-boggling.
It's really challenging, of course. It's something completely new, not been done before.
But a giant lifting system requires a giant ship. And building a vessel of such great size and complexity provides an unprecedented construction challenge.
The size of the vessel already makes it difficult. Almost 200,000 tons of steel you have to produce, weld, install. And on top of that, we also have, of course, various complex systems on board, which many yards are not used to.
The length, the water displacement, the width, it is a unique ship. It is bigger than all the other things it did before.
So how do you build a megaship of such epic proportions that can pluck an oil rig platform from the sea? Engineers at all seas would look to the work of the maritime trailblazers of the past. It seems that, as far as boats are concerned, size has always mattered. And once man had mastered the basics, he was soon building big. Ptolemy IV of Egypt's warship, the Tessara Contreras, was thought to be the world's largest human-powered vessel. At 130 meters, it was meant to be rowed by 4,000 slaves. But in practice, it wasn't very mobile.
Don't forget it.
In 1625, King Gustavus Adolphus of Sweden commissioned his giant warship, the Vasa.
Fantastisk.
But top-heavy with 2 gun decks of brass cannons, a small gust of wind pushed her over on her maiden voyage. Luckily, some more effective build techniques were on the horizon. In Baltimore Harbor stands one of only 2 boats remaining from a vanguard fleet of Second World War cargo vessels. Naval historian Claude Berube knows them as the Liberty ships.
This is the SS John W. Brown, one of 2,700 Liberty ships built during World War II. She's one of only 2 operational Liberty ships anywhere in the world, and she represents some groundbreaking engineering.
The Liberty ships were a response to an urgent wartime problem. Crucial Allied supplies were being shipped from the US across the Atlantic to European shores. But the seas were heavily patrolled by German U-boats.
The Allies were facing a problem. They were losing supply ships at a dramatic rate.
Replacing the lost ships was proving impossible. The traditional build methods far too slow.
Prior to 1941, ships were built piece by piece, and then they would be riveted together. Well, what you would have is the keel that would be laid, and then you would have the ship's frame or the skeleton, and then you would have the hull also riveted on. Big ships took a long time to build, 6 months or more with hundreds of skilled men. The Allies needed to find a way to build those ships at least faster than the Germans could sink them.
In 1941, Henry J. Kaiser, one of America's most modern industrialists, offered an inspired solution.
Kaiser asked himself, instead of building piece by piece sequentially, what if he built modules across the shipyard, and they would all then be assembled and welded together, and this would save an extraordinary amount of time.
Modules could be built simultaneously in large sections in different locations and delivered to the shipyards. And, inspired by Ford's car production lines, Kaiser replaced traditional riveting with the faster technique of welding.
Well, here we have large sections, prefabricated modules that would be assembled, put together, and welded in the shipyard. And you even see what we have here is the house, which contains the bridge and the wardroom, and that would be welded directly to the deck.
In 1941, Kaiser's prefab ships went into full production in 18 yards across the US. Overall construction time was cut by around 2/3, with each ship taking an average of 42 days, with one record build of just 4.
Kaiser's shipbuilding program proved successful beyond expectation. Many believe that without them, the war would have been lost, earning them the title Liberty Ship. Kaiser's shipbuilding program really changed shipbuilding forever.
Engineers on the pioneering Spirit are taking Kaiser's methods and employing them on a gargantuan scale. Built using the block method at almost 3 times the size of a Liberty ship, it is prefabrication on an unprecedented scale.
A normal ship consists of 60 to 70 big blocks, but this ship almost consists of 1,000 blocks, which were then pre-assembled to pre-erection blocks, and those pre-erection blocks were built or dropped in a dock, and there they were welded together.
Before sailing to her home port of Rotterdam, Pioneering Spirit is constructed in the Daewoo shipyard in Korea, only one of 4 shipyards big enough for the job.
The Korean shipyards are used to building big ships, but this ship was massive.
And the ship's unique shape means the prefabrication method can be taken one step further.
You have to consider, we didn't build it as in one dock. We built the portside hull in a dock and a starboard hull in another floating dock. And eventually we brought her together along the quayside. She's a split hull, how we call it, because she's not really a catamaran.
We need to have this shape, otherwise you can't move around different kind of sizes of topside and to connect to the topside.
Even with prefabricated units, the ship is so huge it takes 4 years to build.
The amount of man hours, the amount of welding work involved in that was 2 to 3 times as much as they expected. I have seen 8 vessels leave there, and this vessel was not even finished, basically because of the amount of steel involved. It is not really a vessel, that's what I always think. It's a big working island.
Pioneering Spirit's engineers have created a unique ship. But to achieve the ambition of physically lifting a rig from the seas, designers have to draw on yet more innovations from history.
Feels a bit like riding on a magic carpet.
To make the impossible possible. Oceanic mega vessel Pioneering Spirit is at the vanguard of the offshore construction industry. Built to salvage rigs in one gigantic lift and lay pipe in the planet's deepest waters, for Vice President of Innovation Andre Steenhuis, this ship is the engineering project of a lifetime.
The capacity of this vessel is quite unique. You've got 1 million tons of displacement. The length and the width are huge. This vessel has completely changed how the traditional industry works.
The ship's unique design means it can pick up an oil rig topside in one epic lift.
What we do with this concept is that we don't lift a platform from the top, but we actually push it off from the jacket.
To begin the platform lift, Pioneering Spirit must first lower cutting torches down each leg of the platform in preparation. Then the ship maneuvers into position. But this is not plain sailing. The dual bows must slide under the topside with room to spare.
We need to be able to increase or decrease the draft of this vessel to make sure we could get underneath a platform, which are all at different heights at sea.
So how do you safely position a 900,000-ton ship under an oil platform in potentially hostile waters? To achieve this, the designers need to draw on the accomplishments of history's great engineering pioneers. Science journalist Leila Nelipour is traveling across the seas of Central America to a remote Panamanian archipelago to investigate an extraordinary engineering mystery.
Cuando entras al agua, entra por el costado ese, mira. Las dos piernas para afuera, más fácil para bajar.
A secret that is only revealed twice a day.
So we're on a beach on San Telmo Island. And when the tide is high, there's nothing really to see. But once the tide goes low, amazing wreck. The locals surrounding this island have thought for a long time that it was a wreck from a Japanese submarine from World War II. It wasn't only until about 15 years ago that the archaeologist James Delgado found out the significance of this iron machine.
The answer to the mystery lies in the name given to this region. These are known as the Pearl Islands. For centuries, locals had free-dived the rich oyster beds looking for the valuable treasures. But by the mid-1800s, the number of oysters within reach were dwindling. In 1863, sponsored by the Pacific Pearl Company, American engineer Julius Kroll proposed an audacious solution: a hand-powered submarine that could dive deeper than any other before. And this once ignored wreck is it.
What's so special about this submarine is that it used a water ballast system to submerge. And it was actually the most sophisticated system of its time.
Pressurized with air pumped into it from a ship above, the Explorer pioneered a system of flooding and blowing water ballast tanks, now familiar in all modern submarines.
The way the people inside the submarine fetched the pearls is that since the submarine was completely pressurized, it was able to go to the bottom of the ocean, and then it had a hatch at the bottom of the structure that they could just open and the water wouldn't come in. So it could just reach out to the bottom of the sea and fetch all the oysters.
The concept of water ballast tanks is deceptively simple.
So this is the principle of the submarine explorer. We have a tank here, and as we fill it with water, it will sink to the bottom. So when they wanted to bring the submarine back up to the surface, they used the compressed air tank. And they pumped compressed air into the water tanks to push all the water out. So now I've blown air into the tank full of water. Some of the water has come out, and it has allowed the tank to come back up to the surface.
What Julius Kroll did was to take this crude principle and develop it to unheard of levels of sophistication.
What was so innovative about this water ballast system is that the submarine actually had the tanks placed in different parts of its structure. So it allowed it to control if it wanted to go down nose first or tail first, and also allowed it to control the trim of the submarine as it was descending.
Despite, or perhaps because of its genius, the Explorer developed an unwanted supernatural reputation. Its crews became ill, and many died. Today, we know they suffered decompression sickness, or the bends. But in the 1860s, this condition was little understood, and the divers thought it cursed. Which is why it has lay abandoned here for a century and a half.
Leaving the fate of the submarine workers aside, this was still a very technologically advanced piece of engineering, and it's amazing to be able to see it and feel it and touch it, something that has been with us for over 150 years.
Engineers on mega-vessel pioneering spirit upscale Kroll's innovative use of ballast to a whole new level of sophistication. Captain Fred Recto is at the controls.
We got over 87 ballast tanks, of which are 4 quick drop tanks. The biggest single tank is already 15,700 cubic meters, which is normally a big vessel. In total, we can occupy about 750,000 cubic meters of ballast water.
To position under the rig at a safe distance, the ship takes on enough ballast to increase its draft a further 17 meters.
What we don't want is once the yokes or the beams are close to the platform, that they will hit the platform.
Once in place, Pioneering Spirit can begin the lift process. First, the ship must connect a series of yokes to the platform. But this poses a dangerous problem.
You have to be able to compensate for all the vessel motions when you're moving in the platform. If you don't have that, the collision impact will be enormous and the project will finish.
So how can engineers accurately connect to the rig when the ship is constantly moving? The team on Pioneering Spirit would look to the work of the innovators of the past. This is the Linas-Morlery racetrack near Paris. And this car, driven by Suzy Shi, is one of the cleverest ever built.
This is the Citroën DS, a true icon of French motoring. And while she's undoubtedly a thing of absolute beauty, it's actually the engineering underneath the bodywork that makes it truly remarkable.
By the 1950s, mass production and new technologies were helping to bring cars to the people. But not necessarily comfort.
Here in France, a combination of poor quality roads and the early spring-based suspension systems meant that if you wanted to travel at speed, the ride was going to be pretty uncomfortable. However, there was one young French engineer determined to find a solution.
And in 1955, that engineer was Citroën employee Paul Magès. His ingenuity would override conventional suspension engineering once and for all.
Now, conventional suspension systems are based on springs, but because a spring always maintains the same stiffness regardless of how much you compress it, there's always a compromise to be made in handling. So if I have a soft spring like this one, it's pretty good at absorbing fast bumps and jolts in the road. But when I'm going around corners, the softness means my handling is a little bit compromised. If I go, though, instead for a stiffer spring like this big one here, it's not very good at absorbing bumps in the road, but it's much better through corners with handling. So essentially there's a catch-22 here. If you want a really comfy ride, your handling is going to be affected. But if handling is your top priority, then it's not going to be a very comfortable experience.
Magès took a hugely innovative approach. He got rid of springs altogether. Instead, a sphere is attached to each wheel by a rod and divided by a rubber membrane. The top contains gas, which compresses and absorbs force, and the bottom hydraulic fluid, which transfers it. On impact, the rod pushes into the hydraulic fluid, transferring force to the membrane, compressing the gas above and absorbing the impact. Any excess force is dissipated by pushing the non-compressible hydraulic fluid through a valve.
So we're going to put Magès' design to the test by driving the DS on this incredibly bumpy road. Now, for most cars with a conventional suspension system, this road would be horrendous. It would be really bumpy, really shaky. So let's put the DS to the test and see how she goes. This is really quite amazing. I mean, driving down this really bumpy road in my car or a normal car, I'd be feeling lots of jolts and bumps, but in this car I can't feel them. Because we're riding on this kind of cushion of air, it seems to absorb all of the sudden shocks and jolts from the road. So I really think Magès' system, it works. Not only can it cope really well with bumps in the road, but it actually has another trick up its sleeve. It has an automatic self-leveling system, so that regardless of how much weight you put in the car or where it's placed, extra hydraulic fluid will be pumped around into the spheres, which will compensate for the weight and bring it back up to its optimal ride height. In fact, the system is so clever that it can even compensate for having a wheel missing. Absolute genius.
The Citroën DS is considered one of the most influential cars of all time. its hydro-pneumatic suspension system has been employed on everything from Maseratis and Rolls-Royces through to ambulances. Engineers on Pioneering Spirit are employing the same principles as Magès as part of a spectacular stabilizing system.
When the vessel is moving around the platform and we switch on to AMC, how we call it active motion compensating.
The topside lift system consists of 16 giant beams, 8 per hull, each weighing 1,800 tons. Each beam houses cylinders containing pressurized air, separated from hydraulic fluid. Similar to Magès spheres, the air acts as a buffer to dampen the cylinder movements.
The combination of the hydraulics and the air system what we have, that makes it actually a big and a giant shock absorber. Yeah?
The hydro-pneumatics work to cushion impact of rough seas. In combination with the entire motion compensation technology, it creates a cutting-edge system.
All beams can move in all 3 degrees of freedom, so X, Y and Z direction. The key aspect in the whole beam system is all the hydraulics and the pneumatics involved to make sure that the beams can compensate for all the vessel motions due to the waves. We always say that the beams are standing still in the world and the vessel is moving. I haven't seen that before. It's very, very impressive.
To begin the epic lift, the beams are positioned in sequence under the topside. The motion compensation system is activated, and the torches inside the jacket legs cut them free. The hydraulic system is engaged, and Pioneering Spirit picks up the topside in one staggering lift.
Then we simply push one button, which eventually pushes a lot of oil in a very short time through the fast lift cylinders at the front of the beam, pushing the lever up and creating more than 2 meter clearance between the topside and the legs.
So far we already have successfully lifted 13,500 tons in one lift. We can lift 48,000 tons on the bow, 25,000 tons on the stern, so which is quite unique.
For the whole industry, it will be a big, big game changer.
But salvaging giant rigs in one lift is just part of what this groundbreaking ship can do. To conquer further deep ocean missions, Pioneering Spirit needs to draw yet more inspiration from the innovators of the past.
And this was it, the Lombard steam log hauler.
To make the impossible possible. Pioneering Spirit is the most innovative oil rig salvage vessel on the planet. The length of 5 jumbo jets, this metal-muscled monster can salvage rig platforms in one gargantuan lift. For site coordinator Dan Akkerboom, it never fails to impress.
We wanted to create the biggest and the heaviest lifting vessel in the world, meaning we can lift off now almost 48,000 tons.
Not only can it salvage rigs in one lift, but for Vice President of Innovations Andre Steenhuis, this $3 billion ship is a cutting-edge multi-purpose oil industry tool.
Time is money, so we have to keep on working as long as possible. We wanted to have the double functionality on this vessel, because when you do the heavy lifting, the vessel is occupied for a very short time. And the other time, when we are waiting, we can also lay pipe.
Pioneering Spirit is tasked with laying the largest scale oil and gas pipe in some of the deepest waters in the world. But extreme lengths of large pipe can weigh up to 2,000 tons. Unless the pipe is held firmly and fed out with the right tension, it would buckle under its own weight.
We have to find another way to explore the deeper findings of oil, and therefore you need to have a vessel which has lots of capacity and possibilities to install pipelines. To lay heavy pipe in deep water, it is difficult.
So how do you control heavy pipe lay in deep and difficult water? For engineers on the pioneering Spirit, the solution would lie with a groundbreaking innovation of the past.
Roughly 90% of Maine is forest, more than any other state in the US.
Mechanical engineer Michael Tobias has come to the pine tree state of Maine to discover how the logging industry inspired a revolutionary design.
As far back as the early European settlers, these timbers have been used as a valuable source of income.
Loggers would fell the trees closest to the river first, and log drivers would use the current to ride the trees down the river to the sawmills built along the banks.
However, once the trees closest to the banks were chopped down, a problem started to arise.
Pulling heavy timber from the deeper forest on traditional carts was impossible, as cart wheels would get bogged down in mud and winter snows.
With thousands of acres of forest being rendered untouchable, a solution had to be found, and quickly.
In 1901, inventor and lumberjack Alvin Lombard, who'd experienced the problem firsthand, was set the challenge. We can demonstrate the issue Lombard faced with some boots and some good old Maine mud.
As I step onto the mud, I slip and I sink. A lot of weight is resting on a small amount of surface area. To overcome this, I need to spread my weight on a larger surface area, keeping myself afloat. And when I get the piece from behind me and lay it down in front of me, I'm able to continue moving forward with evenly distributed weight.
Taking this concept, Lombard came up with a machine that would change the industry and the world forever.
And this was it, the Lombard steam log hauler. What an amazing machine, incredible.
And the secret of its success lies beneath the machine itself.
The genius of Lombard's design is its continuous tracks, spreading the vehicle's weight across the ground and providing even traction. It effectively lays its own roadway.
No longer having to rely on wheels, the continuous tracks of Lombard's machine made it an instant success.
The Lombard would typically tow 8 sleds laden with lumber, weighing in at a massive 300 tons.
And able to be used all year round, it was the first commercially successful continuous tracked vehicle.
Lombard's design was a stroke of genius, and this machine would revolutionize the way engineers around the globe would design and build vehicles for agriculture, construction, and military use. What an incredibly engineered machine.
But how does an all-terrain log hauler relate to a giant offshore construction ship? On Pioneering Spirit, 4 gigantic tensioners in the ship's firing line are each fitted with 100 meters of continuous track. Just like Lombard's log hauler, the tracks increase the surface area in contact with the pipe, evenly distributing tension, enabling a controlled delivery to the ocean floor.
Here we are at the aft of the production line, and here you can see one of the 4 tensioners which we have from the Pioneering Spirit. One of the tensioners can have a capacity of 500 tons. The pipe is clamped in between tensioner shoes. Shoes can move a little bit, so they've got the optimum position. So they've got the optimum pressure on the pipe, so you don't damage the pipe. The straps on the pipe hold the pipe continuously on the vessel.
The tensioners play a crucial role in the onboard pipe assembly line, where the joints are welded together at different stations.
The welding platforms where the guys are standing on are moving along with the pipe during the production of the pipe.
Engineers on the ship are able to produce 400 meters of large gauge pipe every hour. Once welded, the megaton pipe is gripped by the tensioners. It's then fed continuously out over a giant stinger to the sea floor.
Because we have these tensioners, we can lay deeper pipes. We have less environmental issues with the pipe. There's no sea in the world where the Pioneering Spirit cannot lay a pipe.
Pioneering Spirit is pushing the boundaries of deep sea oil exploration. But to complete this incomparable vessel, engineers would once more need to draw upon history's greatest innovators.
It really worked. I mean, it's surprisingly strong.
To achieve even more impossible engineering. Pioneering Spirit is a $3 billion ocean colossus. At its deepest draft, it reaches a world record displacement of 1 million tons of seawater, making it the heaviest floating object on Earth.
There's nothing in the world ever built like the Pioneering Spirit. She's unique in size, in weight, and in operation.
This epic vessel's mission is to clear redundant oil rigs from the high seas, which it does in a unique and innovative way.
We can go underneath the platform and make sure that we position the beams underneath the platform and then are ready to lift her off the jacket.
This mighty ship is also designed to lay the world's largest gauge oil and gas pipes for a new generation of deep water rigs. But pipe laying can take many months, and the environment is unpredictable.
You have to go more out in the deeper waters, so you're much more exposed to difficult weather conditions.
Violent storms in exposed seas pose a threat to even this marine colossus, as site coordinator Dan Akeboom knows only too well.
If the weather changes or suddenly big waves come, they have to stop and abandon the whole operation.
But how do you safely stop and disengage hundreds of tons of pipe onto the ocean floor over a mile down in a raging sea? To overcome this problem, engineers would need to turn to the innovators of the past. Dr. Susie Shi has travelled to Germany to discover a brilliant invention that helped revolutionize the mining industry.
This is the Upper Harz, one of the most historically important mining regions in Germany. Mining has taken place in these hills for centuries.
But 19th century mining engineers had a problem. How do you reliably get tons of valuable metal ore out of the mine?
Once it was chiselled free from the rock, it was loaded into large wooden buckets so it could be hauled up to the surface. Some of the shafts reach a staggering depth of 800 metres, which was below the sea level, so that ore had a long journey all the way up to the surface.
Originally, the buckets were lifted with hemp fibre ropes.
But in these damp conditions, the moisture would cause ropes to disintegrate, so instead they used chains. But chains weren't much better in terms of safety, because a single weak link could cause a catastrophic failure with no warning.
In 1831, mining engineer Wilhelm Albert began working on a new system, which we can demonstrate using tissue paper.
Albert determined that there were a few key factors as to why chains were breaking. He realised that if you load a chain again and again, eventually the metal will become fatigued and that will reduce its tensile strength. And breaks in the chain are more likely to happen where there's joins and links. All it takes is a single point breakage for the whole system to fail. Oh, it just completely failed. This is incredibly dangerous. I mean, you can imagine 1,000 pounds of silver ore crashing down on your head. After experimenting with chains for a while, Albert realised that he needed an entirely new solution. And what he came up with was simple, but ingenious. Albert's idea was to take 4 individual strands of wire and then twist them together to form a helix. He'd then take 3 of those and twist those together to make it even stronger. So this made a kind of wire rope, and you can tell already it seems much stronger and it should be able to take a much heavier load. So let's try it out. So it really works. I mean, it's lifting a surprising load. It's surprisingly strong, even though it's made of tissue paper. The secret to its success is the continuous strands. There's no individual joins or linkages that can fail. And here I have an original piece of wire rope, and you can see that it's made up of individual strands, just like the demonstration. Albert rope, named after its inventor, was so successful that he soon installed it in mine shafts all across this region. In fact, wire rope caught on all across the globe, and not just in mines. You can see versions of it in the modern world, from suspension bridges to cable cars.
Aboard the ocean giant pioneering Spirit, Wilhelm Albert's wire rope has been used on a colossal scale as part of a deep-sea abandon and recovery, or A&R system.
When you are installing a pipeline and you're midway and the weather's picking up, bad weather or even a hurricane, you have to abandon the pipe. So in that situation, you weld on the end of the pipe to weld ahead.
The end of the pipe is made watertight by welding a cap on the end. Then, using super heavyweight wire cables, it's lowered to the ocean floor and cut free by an underwater robot.
This is the cable, 5-inch cable, it's quite big, and 4,850 meters of length, able to lay down the pipe with 500 tons each, so a total of 2,000 tons of lay-down capacity. This system looks very large, but it has to act very precise.
To achieve that precision and control, engineers on Pioneering Spirit have created an ambitious system.
Our A&R system has 4 of these winches. These are the biggest winches you can buy. For the biggest pipelines, you need all 4 of them.
And to ensure accuracy when using all 4 giant winches, engineers have built in a fail-safe design.
Here I've got a right-handed cable, so you can see the helix is going up to the right. And the other side of the vessel, we have got also 2 of these winches. they are left-handed, so the helix is going in the other way.
The left and right helix mean the cables cannot intertwine.
We can play with the tensions and we can rotate the cable so we can connect the cable to the pipeline. This is unique to the world and to the pioneering spirit.
Through design and engineering, pioneering spirit has raised the bar for what is possible for the oil industry.
We can lift over 48,000 tons. We're twice as big as the second biggest pipe layer in the world, so we create our own jobs.
If you're an engineer, this is a dream of everybody, to be involved in this project.
To be involved in the development and designing and building a vessel like this is very unique. You never get a chance to make something which changes the industry.
By drawing from the innovators of the past, adapting their ideas and making trailblazing discoveries of their own, the engineers and designers behind pioneering spirit have succeeded in making the impossible possible.
People ask me, oh, what are you going to do afterwards? And I don't know. I mean, we built the biggest ship in the world, so what's next? I don't know.